we're beginning to solve systems, and today we're going to be doing that by graphing. There are two other methods that we'll be using to solve systems of equations, but right now today we're only going to be using graphing. So what is a system of linear equations? Well, a system of linear equations is two or more linear equations. What's a linear equation again? Remember, that's an equation that makes a line. So in this first example, I have two equations that make lines. What we want to know is if 8, -1 is a solution, meaning is it on this line and is it on this line? Well, how we're going to be able to tell that is by plugging in our x and our y values and asking ourselves whether or not it's true. So if x is 8 minus if y is -1, does that equal 9? And the answer is yes, it does. So yes, it is a solution to the first line. Now the second one, we have to take 2 and we have to plug in the 8 plus 3 times the y, which is -1 equals 13. Well, 2 times 8 is 16. 3 times -1 is -3. Does this equal 13? Yes, it does. Because it works for both equations, it must work for both equations, we can say yes, it is a solution. This next problem, we're doing the same thing. We're going to check whether or not 2 -7 is the solution. So this is my x and this is my y. I'm going to plug in 2 minus my y value is -7. Does that equal 9? That's the question we're asking. Yes, it does. So then what I'm going to do is I'm going to plug in my x value and I'm going to plug in my y value and I'm going to ask myself if it equals 13. Well, this gives me 4 plus -21. Does that equal 13? No, it does not. Because it does not work for the second equation, this is not a solution to the system. So it can be a solution to one, but not a solution to the other. And if that happens where it's not a solution to the second one or the first one, we know it's not a solution to the system. It has to work for both equations. So there's 3 types of graphs that can occur. So the graphs of linear systems, one of 3 things can happen. You could have intersecting lines. When you get the intersecting lines, this is the solution. So this is the solution. So where they intersect would be the solution, meaning that point is on both of those lines. The second thing that can happen is you could have parallel lines. If you have parallel lines never intersect. So when you have parallel lines, we will say that there is no solution, meaning there is no point of intersection. The third thing that can happen is that you can actually have the graph and you have the same line. You can barely see that. I have a pink line and a green line. They're lying on top of each other, so you have the exact same line. The type of answer we would put here is infinitely many solutions. So on this type of problem, we would have infinitely many solutions, meaning it intersects everywhere, so we don't even know how many solutions there are. There's infinitely many. So in a review or synopsis of what I just said, if you have intersecting lines, you have one solution. If you have parallel lines, you have no solution. And if you have the same lines, you have infinitely many solutions. Those are very, very, very important. We've got to know those. So when we graph, we're going to graph both the lines on the same coordinate axes. We're going to find their point of intersection. We're going to use the extended slope, so we're going to do rise over run many times so that we can find that point of intersection more easily. And then what we're going to do is we're going to write that intersection point as an XY coordinate. So beginning on this next video, I'll go through the first example and I'll graph both of these lines and then we'll find the point of intersection.